calculator for this one. All right, we have a problem here. There are a bunch of people in a room. They're students. And 55 of them leave. And after 55 leave, that means that 7/12 of the original number remain. And our question is, how many people did we start with? So we can do a simple guess and check table. That's what we'll start out with, all right? So let's just say we started with, 100 people. Let's see, and then 55 leave, so that's 45 remaining. And then let's see, what fraction remain out of the total? Well, let's see. Let's go 45 people remaining, so 45, clear. 45, ABC 100 is 9/20ths. 9/20ths. Well, not 7/12ths. Let's try maybe, fewer people. Let's see what happens. Let's say we started with 90 people. And let's see, that would leave, if 55 leave, that's 35 remaining. So, what is 35 out of 90? That would leave 7/18ths. 7/18ths. Let's pause for a second. We have kind of a problem here. We could keep guessing and checking, but unless we can decide about our fraction overall, we have a. It's hard for us to say. Let me pause for a second. I'm going to rewind all this. Okay. I need to be able to decide, is 9/20ths bigger or smaller than 7/12ths? Is 7/18ths bigger or smaller than 7/12ths? And if it's bigger or smaller, does that mean I need to guess a larger number or a smaller number next? Okay. So, one thing we could do is we could find like common denominators here for 7/12ths and 9/20ths and 7/18ths, and we'll decide based on that what's going on here. So let's see, or we could, and let's go ahead and do that. So for 12 and 20, a common denominator would be 60. So let's see, 7/12ths, we'd have to multiply times 5 and 5, that's 35 out of 60, versus 9/20ths, so we'd have to multiply that by 3 over 3, gives us 27 over 60. Okay. So we are, let's see, 27 to 35. We are, let's see, that's 8/60ths off. Okay. And then down here, let's see, we have 7/18ths. Let's see, 7/18ths, 18ths and 12. Common denominator would be 36. So 7/18ths, we'd have to multiply by 2 over 2. That's 14 over 36 versus 7/12ths. Let's see, we'd have to multiply by 3 over 3. That's 21 over 36. So that means that we're currently 7/36 away. Now, we get is what 8/60ths and 7/36ths. Which one of these is bigger? Are we getting closer? Are we getting smaller? So I guess now I could find a common denominator here and figure out which one is bigger or smaller. It's starting to get complicated. So let's try something different. Let's turn these into decimals. Okay. So I'm going to go 9 divided by 20 is 0.45, and that's exactly 0.45. And 7 divided by 18 is 0.38, repeating. So 0.39 approximately. So we can tell that our fraction is getting smaller. Right, went from 0.45 to 0.39. Now let's check 7/12ths. 7/12ths is 0.58 approximately. 0.58 approximately. And so if we went from 0.45 to 0.39, we are not on the way to 0.58. Okay? So let's try going the other direction. Let's try 110. That would leave us with, let's see, 110 minus 55 is 55. And 55 divided by 100, which is 0.55. So that's 55 hundredths, which is equal to 0.55. So we're getting closer to that 0.58. Let's try 120. Take away 55, leaves us with 65. And what is 65 out of 1? Oh, wait a minute. That should be 55 out of 110. Clear. 55 out of 110. Oh, it's just 0.5. Okay, there we go. So we're getting closer still. 65 out of 120. 65 out of 120 is 0.54. So that's 65 out of 120, approximately 0.54. So we're getting closer. Let's try 130 next. 130, take away 55 is 75. So 75 out of 130 is 0.5. We'll round that to 0.58. Now, this was rounded to 0.58 too, so we're getting really close. Let's call this 0.577, and that was 75 out of 130. 75 out of 130, which is approximately 0.577. And let's double check our 7/12 number. 7 divided by 12, that was 0.583. All right, so we're getting very close now. Let's try 140. Let's see, 140 would leave us with 85 remaining. 85 out of 140. So let's go 85 divided by 140, 0.61 approximately. Okay, so here's where we've overshot it. All right, our portion remaining was getting bigger and bigger and bigger and bigger, and then we overshot it. So we're somewhere in here. And let's try. We could fish around a little bit, but the answer is 132. If there are 132 people in the room, minus 55, that leaves us with 77. And 77 over 132 is 7/12. Exactly. So that's the number we were looking for. All right, so just to go back over our process here, despite some mathematical errors along the way, we just guessed that there were 100 people to start with. We calculated how many people were remaining, and then we were saying, okay, well, if we take away the 55, so this is, minus 55, what remains? And then we calculated what fraction is that of the original, and we were shooting for 7/12. So dealing with all these fractions is a little complicated, so we can get approximate decimals. We say, okay, we started out with 0.45, and then went down to 0.39, and that was the wrong direction because 7/12 is about 0.58. So we do go up, so we went up to 110. That gave us a fraction of 0.5. 120 meant 65 people remaining, and 65 out of 120 was 0.54. So we're getting closer to 0.58. And then we got closer to 0.58. And then at 140, if there are 140 people in the room, there were 85 remaining after 55 left, and 85 out of this original 140 was 0.61 approximately, which means we've overshot our 7/12 fraction that we were looking for. So now we could have gone back to like 135 and then 134, 133, 132, but I kind of cut to the chase here. 132 out of take away 132, take away 55 means there were 77 people remaining, and 77 out of 132 reduces to 7/12. So there are 7/12 remaining. Now, we could talk, that's a whole complicated process. We could kind of short circuit it a little bit if we just look at what we're doing. Okay, so think here, we've got a starting number, which we don't know, so we'll call it x, a remaining number, which is x minus 55, and our fraction is calculated by taking remainder over start. So, like for example, here we had, 9/20 was reduced, but that was 45 out of 100, 35 out of 90, 55 out of 110. So I could say it's x minus 55, that's our remainder, over our start is equal to 7/12. That's what we were shooting for. And it's a little matter of cross multiplying here. We have 7x and 12 times x minus 55, 7x, do a little distributive property thing over here. Let's see, 12 times negative 5, or 55, so I'll use my calculator off of that one. 55 times 12 is 660, so that's minus 660. And then I will subtract 12x from each side. That gives me negative 5x equals negative 660. And I'll divide both sides by 5. And we get, divided by 5, gives me 132. Okay. So again, we could go through this kind of long, tedious process of guessing and checking. Or after you do a couple rows, you think, what am I doing here every time? I'm starting with a number. I'm subtracting 55, and then I'm taking that remainder and dividing it by the start number to see if it's 7/12. So again, I start with a number, I subtract 55, I divide by the starting number, and it should equal 7/12. And then I just have to go ahead and solve for x using the awesome power of algebra to end up with x is 132. And then we could always go back and check to make sure that actually works. 132, take away 55, leaves 77. And 77 out of 132 is in fact 7/12 of the people that remain. Whew, that was a long one.